A very warm welcome to all of you for today's lecture. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. This particular lecture will form a part of the lecture 8, which is on the characterization of bituminous-bound materials under the module 3 of the course. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, when we talk about bituminous-bound courses, automatically the term comes bitumen. Now, this bituminous-bound mixes will have a combination of the bitumen, will have aggregates. These are the two major components, and there may be other class if we are putting up some additives to it. So, we can basically classify the bituminous courses of flexible pavements or the composition of bituminous mixes into three individual constituents. One will be your bituminous binder, the one which is going to bind your aggregates, which again falls under different categories of coarse, fine and filler. Along with it, there may be certain additives which may be used to impart some specific characteristics, but the two main components will be your bituminous binder and the aggregate. Now, how do we produce it? These bituminous mixes are produced at hot mix plant. Most of the bituminous mixes are produced at hot mix plant. Certain small works may involve some on-site preparation of some specific category of bituminous mixes. Otherwise, always a hot mix plant is preferred, and we call it as a hot mix plant because the production is at higher temperatures, at elevated temperatures. So, bituminous mixes are mainly produced through a hot mix plant of adequate capacity. It depends upon how much quantity of production you require per hour, and capable of yielding a mix of proper and uniform quality. This is important because here a control is there with respect to the uniformity of the mix in terms of aggregates, binder, in terms of the temperature at which the mix is produced, so as to have a thoroughly coated aggregates. This is what the purpose is. Now, when it comes to bitumen, so when we are looking into the characterization of individual materials of bituminous-bound courses, as in the previous lecture, we looked into the characterization of aggregates when we were discussing about the unbound courses. So, a certain classification of aggregates remains same, only the requirement of individual values of particular characteristics will differ when you are using it in granular courses or when you are using in a bituminous-bound courses. In this lecture, we will first start with our discussion on the characterization of the major material, which is the bituminous binder. Now, this bituminous binder is known by different names. It is known by bitumen, we can call it as bituminous binder, and also as asphalt binder. So, what it looks like, it is a dark viscous material and ranging from solid, semi-solid or liquid form. So, its consistency changes with change in the temperature. This is what a thermoplastic material is. Its consistency or its fluidity changes with the change in the temperature. And so, it is a dark brown viscous material ranging from solid, semi-solid or liquid form with a strong adhesive and waterproofing properties. This is very important characteristics of this material. And from where do we get this bitumen? We get it from the refining of petroleum crude. This is the major source. When the refining process of the petroleum crude started with the growth of the automobiles, a lot of bitumen also got produced, and the use of this bitumen, which is derived from the refining of petroleum crude, became very popular. In addition to this, it occurs naturally also in terms of there are certain sources, there are certain lakes where natural asphalt is also occurring. So, but once this refining of crude, petroleum crude came into picture, the quantity and the quality of the bitumen which was derived from it was very good, and therefore, it became more popular compared to natural asphalt. and this material is completely soluble in toluene and trichloroethylene. This is a definition which is as per IS 334. Now, under this bituminous binder, there are normally 4 different categories which are there, which are popular specifically for bituminous pavement construction or flexible. The first one is paving bitumen, the most common or the most widely accepted popular type of bitumen. The second, if I modify certain characteristics of this paving bitumen, it can come under the category of modified bitumen. The modification can be done in different manners. It can be through some additives of some polymers. I can do some additives by some waste materials, any say like waste plastic, waste rubber, all these, some synthetic polymers, elastomers, plastomers. When added, it comes under the category of modified bitumen. Then there are 2 other categories, especially cutback bitumen and emulsified bitumen. One application of this particular one is when you want to produce the mixes at ambient temperatures. So, you do not need to heat your binder. So, then you go with the cutback bitumen and emulsified bitumen. So, the one which is most popular and widely used is the paving bitumen, and this is what we are going to look into the characterization. The choice of bituminous binder is to be clearly stated in the contract by the engineer. Whenever a project is to be there, it has to clearly define what type of binder is to be used. Now, as I mentioned, there are various IS specifications, IRC specifications. This is BIS specification 73, paving bitumen specification. This is SP 53 on use of modified bitumen. IS 15462, again polymer modified bitumen specification. IS 217, cutback bitumen. IS 8887, bitumen emulsion. IS 17079, which is rubber modified bitumen. So, we have different specifications available from BIS as well as MORTH and IRC to refer for these different type of binders. Now, why this bituminous binder is so popular in road construction? It is popular because of its some inherent characteristics. One of the inherent characteristics is its excellent binding characteristics with most of the aggregates. It sticks nicely with most of the aggregates, you can see. So, this is the stickiness nature and which is there with most of the aggregate types which we are available. So, that is the wonderful character. Second is waterproofing characteristics. It is a water repellent material. You might have heard bitumen is used as a waterproofing in various industrial applications. This is one picture. It is a very old picture shown. It shows a 75 centimeter long boat made up of bitumen mixed with earth in southern dates to Akkadian period in Mesopotamia. So, around 2300 BC. So, because the waterproofing nature of bitumen was known at that particular period of time, even this bitumen was used in mummification also. So, this characteristics of bitumen is very important, which made its use widely popular in the construction of roads. And other part is, since it is earlier, it was extracted as a sort of residual during the refining of crude petroleum crude. So, it was relatively low cost also, but with the gain in the popularity, with the increased demand of the bitumen, the price is increasing. Now, so we have asphalt binder. This is another term which is used as bituminous binder, dark brown to black in color, naturally occurring or produced by petroleum crude refining. So, you can see this is a natural a lake where natural asphalt is coming up. So, well beneath the earth's surface due to the pressure, there are certain lakes where we have Trinidad lake is there, where this is getting produced also. This is that example. This is Trinidad lake where you can see they are producing it. Now, here a lot of in this particular one, there will be a share with the bitumen also, and some volcanic ash will be also produced. So, this was used earlier before the refining process became popular. After that particular one, because of the good quality and the abundant quality which was available through the crude refining, this became less popular. And So, there are certain natural sources of natural asphalt also, like one example is Trinidad Lake in the island of Trinidad, then Bermudes Lake is there in Venezuela, and there are certain sands in Western Canada where also a good deposit of natural asphalt is there. And as I said, later on with the growth, specifically requirement of automobile fuel, the refining of the petroleum crude, when it took place in the early 1900s, the bitumen which is derived from the refining of crude petroleum became more popular. So, this is obtained by separating out the different fractions of petroleum crude. You can see this is a distillation chamber, different fractions are separated out at different levels. So, the one which is obtained in this particular one at the lowest is the residuum, which is your bitumen. Now, this is the residual bitumen fraction which is obtained during the, and this is also further refined or processed to get the desired quality of bitumen. There are various ways of further processing it. Degassing is there, air blowing is there, vacuum application is there. So, as to derive the or to achieve a composition of bitumen which is suitable for our road construction. Now, when you have this bitumen which is derived from refining of crude, there you need to you can get it from different sources. We have a good number of refineries in India also, more than 10 number of refineries are there in India. They use some of the crude which is getting produced in our country, and a good amount of crude is also imported from other countries. Now, when we have this bitumen obtained from these different refineries, we need to compare those bitumen to ensure their quality. So, certain parameters are to be ensured for the bitumen to judge its suitability in road construction. So, under this particular one, we have few divisions to ensure the quality or the suitability of a bitumen for our road construction purposes. And there are one category which falls under the consistency test, second category is under the aging test, third is purity test, fourth is safety test, and there are few other tests which are also advised while judging the suitability of bitumen for road construction. We will discuss them one by one. Now, first comes the consistency of the bitumen. As I mentioned in the beginning, that bitumen is a thermoplastic material, its consistency varies with the change in the temperature. So, at lower temperatures it will be a solid or a semi-solid. When I increase the temperature, it becomes it starts flowing. So, it changes from semi-solid to liquid state. So, now if I want to compare bitumen from two different sources, that means I have to compare them at the same temperature. Specifically, that is the important thing, same temperature and same shear loading conditions also. So, for determining the consistency, which says that consistency describes the degree of fluidity of bitumen at any particular temperature. This is important. So, temperature. Therefore, when I need to make a comparison of different bituminous binders, because if I have binder from 4 different sources, I will check which one is the best one or which one falls within my requirements, I will pick up. So, for that particular one category of evaluation is the evaluation of the consistency of the binder, which is very, very important. It is necessary to measure their consistency at the same temperature and shear loading conditions. Now, how do we ensure this fluidity or consistency of binders so that we can compare between different sources? There are 4 tests which are widely used. One is absolute viscosity measurement done at 60 degrees centigrade. Second is kinematic viscosity measurement done at 135 degrees centigrade. The other test is penetration test done at 25 degrees centigrade, and the fourth one is the softening point test. These are 4 widely preferred tests for determining the consistency of bitumen. Now, what is done under the absolute viscosity determination? As we know, viscosity is a fluid's resistance to flow. So, we want to get an idea what is the viscosity of the binder which we are going to use. Now, this is expressed as the ratio of applied shear stress to this resulting rate of shear strain. So, this is what is your coefficient of viscosity. So, when we say about the coefficient of viscosity, it is your tau divided by your shear rate. So, this is your coefficient of viscosity is there. Now, this coefficient is a measure of the resistance of the flow of the liquid and commonly known as viscosity. So, we need to see what is the viscosity so as to get an idea about the fluidity of the binder at a particular temperature. And another aspect which is important with respect to bitumen, we have you might have read in physics, there are two types of liquids are there. One is Newtonian liquids and other category is non-Newtonian liquids. And bitumen is the one which behaves both as a Newtonian as well as non-Newtonian one. And it says in a non-Newtonian fluid such as bitumen, and specifically at temperatures lower than 100, it behaves as a non-Newtonian fluid. And what is that? That the relationship between the shear stress and strain rate is non-linear. So, you do not have a constant viscosity. That is why you have to define the temperature and you have to define the shear loading conditions to measure your absolute viscosity at a particular temperature. So, the temperature which is recommended is 60 degree centigrade. So, and for this particular one, the code which is referred is IS 1206 part 2 2020 version which is there, 2022 version, and it is mentions three types of vacuum capillary viscometers. One is Cannon-Manning, which is the most widely used, Asphalt Institute vacuum capillary viscometer, and modified Copper's vacuum capillary viscometer. So, three types of capillary viscometers are, these are the pictures of these three types which are shown, are used to measure the viscosity of your bitumen. Now, what is done specifically, broadly I will explain. What is done in this viscosity measurement is, we do this viscosity measurement at a 60 degree centigrade, because this is what was considered as the maximum temperature which can be expected in a bituminous pavement when after its construction. So, this is because it approximates the maximum HMA pavement surface temperature during summer. So, that is why 60 degree was the temperature which was fixed. And Cannon-Manning vacuum viscometer, as I said, it is the widely used capillary viscometer for determination of this absolute viscosity. So, you can see this is a smaller mouth, this is a bigger mouth, this is a Cannon-Manning capillary viscometer tube. You will pour the bitumen in the wider mouth, and once it is poured, you can see this is the mark which you have. Once it is poured, thereafter you will apply a standard vacuum on this other end. So, it says the bitumen is heated to a maximum 90 degree until it becomes pourable, and then you need to pour it, and you need to apply a vacuum of 30 centimeter. So, mercury, so that you apply a standard shear loading condition to this particular one, and then this is while this particular capillary viscometer is there in the water bath, so that the water bath maintains your 60 degree centigrade. So, this is done by keeping your this capillary viscometer in a water bath so as to attain the 60 degree temperature. Now, and what you do, you measure the time which is taken for the bitumen to pass from one mark to the other mark. So, this, and for different capillary viscometer tubes, there are calibration coefficients, there are calibration constants which are there. So, they give, now what you record in this particular one, you record the time taking from one mark to the other, the bitumen it takes from moving from one mark to the other mark. So, here what we do, the flow time for the bitumen meniscus to pass between the timing marks is recorded, and from there you get your viscosity in poise, which is K is your calibration constant and T is your flow time. This calibration constant is given by the manufacturer of this particular tube. So, this is to be given by the, so there will be maybe different calibration constants for different type of tubes, and even from the one which are supplied by different manufacturers. So, this gives you an idea about the consistency of binder at 60 degree centigrade, which is the temperature at which these bituminous mixes have to perform in the field. Second is the viscosity which we require at elevated temperatures, and for that we go for the kinematic viscosity measurement at 135 degrees centigrade. Now, for this particular one, this is a temperature which represents temperature close to your production temperatures. So, and at these temperatures the binder behaves as a bituminous binders, most of the bituminous binders behaves as Newtonian fluid. So, that means their shear stress and is proportional to their shear rate. So, you have now in this particular one, again there are the standard viscometer tubes which are used. The one which is widely used is Cannon-Fenske's opaque viscometer tube which is used. Now, again here you pour the bitumen in one end and you will have this particular bath which is there to control your temperature. Now, here you are going to maintain a temperature of 135 degrees centigrade, and then these tubes are kept in this particular bath, and here again the binder is inserted in this particular one, and you need to ensure, because at this particular consistency, at this particular temperature, the binder moves under the gravity itself. So, it says kinematic viscosity of a Newtonian fluid, which is binder which behaves as a Newtonian at this particular temperature, is the ratio of the viscosity to the density of a fluid, and it is a measurement of a resistance to a fluid under gravity, because at this temperature there is no requirement of a vacuum to be applied, it moves under. So, in the initially there may be a small partial vacuum may be applied once to start this movement, and thereafter it moves under the gravity. So, then again these timing marks are there, and you need to note down the time which it takes to move from one timing mark to the other, and thereafter again the kinematic viscosity at 135 degrees centigrade in terms of the units of centi-Stokes are given as the calibration constant of the viscometer, and other is the efflux times to move from one timing mark to the other. So, these are empirical measurements specifically of your consistency. Indirect measurement, you are getting an idea about the consistency through the viscosity measurement at 60 degrees centigrade and through the viscosity measurement at 135 degrees centigrade, and the 60 degree is giving an idea how the viscosity will be there of binder during its service life, maximum temperature which can be expected, and 135 gives you an idea how the binder will be there during the production, because it has to coat the aggregates in a uniform manner. Now, other test which is quite common for measuring the consistency or fluidity of binder is your penetration test. Now, it is an empirical test and is widely used to measure the consistency of bitumen. Now, what is done? This particular test is done at a temperature of 25 degrees centigrade, which is normally considered as the ambient or the most approximate average service temperature, because you may have lower temperatures also, maximum temperatures also. So, 25 degrees centigrade for most of the region was considered as approximate average service temperature during the year. And this is a simple test where what is done, a binder sample is taken and then a needle assembly is taken, and it is allowed to penetrate under standard conditions into this bituminous sample, and we note down how much penetration is taking place at a particular degree of temperature under controlled conditions. So, I can say if the penetration is more of the needle, then the binder is soft. If the penetration is less, broadly we can speak in this manner, if the penetration is less, then the binder is hard. So, this is how we can compare the consistency of binder. So, the consistency of a bituminous material expressed as distance in tenths of a millimeter, and this the amount of penetration is recorded in 1/10 of mm. So, if there is 1 mm of penetration happens, then the penetration value will be your 10 in that case. So, a standard needle penetrates vertically into a sample of the material under specified conditions of loading time. This is important. What temperature we do the measurements, the most common measurement is done at 25 degrees centigrade. Now, And here important aspects are specifically in terms of your, this is the needle, the dimensions of the needle, the weight of this assembly which is going to penetrate, the amount of time which is allowed for the needle to penetrate, and then you measure your penetration in terms of 1/10 of your mm. So, it says a moving weight, the sum of the weights of the needle, carrier and superimposed weights is around in the range of 100 grams. And we make multiple readings. We this not a single reading is taken up. This is in this particular cylindrical measure. When you are going to take these measurements of penetration, you will take at least 3 repetitions have to be done, and it says that they should be at least 10 mm apart and 10 mm from the side of the dish. So, these are, and the temperatures which are to be ensured. In this particular one, the important part is that the test procedure strictly has to be followed, because it can get influenced by the inaccuracy in the pouring temperature, at what temperature we are pouring the binder into this particular measure, cylindrical measure, the size of the needle, the weight placed on the needle, and the test temperature. So, this any variation in this one will lead to a variation in your penetration amount. So, if I have a higher penetration, I can call that binder as softer. If lesser penetration, the binder is hard. Another consistency test which is used to ensure how the binder will behave, specifically the phase change of binder will happen. As I mentioned, it can be a semi solid at lower temperatures, and when you increases the temperature, it may become soft. So, you might have seen this, that there is sometimes news comes up on some of the road sections that they are getting stick to the vehicle tires, or and especially the roads are getting melting down. What is happening? The binder is becoming soft at higher temperatures. So, for this particular one another, in addition to the viscosity, penetration, there is one popular test to measure the consistency is softening point test. And what it does, the softening point is the temperature at which the binder attains a particular degree of softening under standard test conditions. So, we are going to determine the temperature where a particular degree of softening is achieved, and it says it is an empirical measure that indicates the temperature at which bitumen transits from a semi solid to semi liquid state. So, what I will do under this particular test, I will prepare some rings with a binder sample, and over that a small weight will be placed, and this in this particular cylindrical measure, it will be submerged in water. I will raise the temperature, and I will see when under the weight of this particular ball, the binder in the ring moves down. And so, initially when I started the test, usually this test is started at 5 degrees centigrade, and gradually the temperature is raised. So, there the binder is in a semi solid state, and once the temperature is gradually increased, a temperature is reached where this binder in this ring starts moving down, and it touches the bottom place. So, this gives me an idea about the phase change which is happening in the binder. So, its purpose is to determine the temperature at which an asphalt cement cannot support the weight of a steel ball and starts flowing. This is what happens. Now, this is further some of the more pictures which shows how a softening point test is done. So, these are the steel balls, these are the rings in which the binder sample is poured, and then it is placed in this outer ring, and thereafter you place these steel balls over it, and then this is how the assembly is there. It is kept in water bath, and then you raise the temperature. So, it says the assembled softening point apparatus is placed in a water bath with distilled water at 5 degrees centigrade to 15 minutes, so as to bring the sample to 5 degrees centigrade, and after which the ball is placed and the temperature is raised 5 degrees centigrade per minute. So, gradual increase in the temperature has to be made, and there may be certain binders which may be very hard. So, the distilled water may not be possible to look for those temperatures where this phase change occur. In that case, glycerine may be required if the temperature of the softening point of these binders are more than 80 degrees centigrade, and we exactly check where the binder touches the bottom place, and that is recorded as our softening point. So, if a binder is hard, then that particular one will require a higher temperature to experience this phase change. If a binder is soft, it may move down at lower temperatures. So, this also gives an idea about the consistency of binder. So, after this consistency, there is one other aspect which needs to be ensured for the bituminous binder, specifically the paving binder, is the resistance towards the aging. What is this age? As human being ages, similarly binder ages. Now, how the binder aging happens is, the binder aging happens during the production of the mixes also, because at that particular time the bituminous binder, when mixed with aggregates at elevated temperatures, they form a small film, a very thin film, which may be in the range of around 10 microns or even lesser than that particular one. So, a very thin film is formed over the aggregates, and this thin film, when exposed to those high temperatures, undergoes loss of volatiles in the bitumen. So, when this loss of volatiles happens, when the bitumen, the viscosity of the bitumen increases, or we can say the bitumen is getting oxidized, and we call it as aging of the binder. So, the viscosity of the binder. Now, if this aging is very high, it makes the binder unsuitable at a later stage of service life. So, some good characteristics of the binders are lost. So, that is why we want to ensure how much aging takes place, how much a binder is susceptible towards the aging. So, when a bitumen is mixed with hot aggregates at elevated temperatures in a hot mix plant, it forms a thin film in the range of around 8 to 10 microns around the aggregate particles. The exposure to high heat causes the loss of volatile components of bitumen, leading to a significant increase in viscosity that makes the binder stiff, and this phenomenon is called as hardening, aging of binder, and another term which is short term hardening. Why short term hardening? Because still the binder will undergo hardening when it will be laid and compacted after that particular one, because the road will be exposed to different environmental climatic conditions and loading conditions for a period of 20-30 years. So, during that process also it will undergo subsequently aging. So, what aging happens during the production and construction is taken as the short term aging, and we want a binder to age less comparatively. So, after the bituminous pavement is laid, bitumen continues to undergo long term aging. So, once it is laid, then what the aging happens is considered as the long term aging, which happens during the exposure to different factors. So, what more important is, when it is produced at a hot mix plant, this is a hot mix plant where it is getting produced. So, there, and then it is transported to the site and it is laid and compacted. So, this particular process from here to here up to this one is your, so this both production as well as construction, the aging which is done, which happens during this period of time is your short term aging, and what happens to this particular short term aged binder during service life is long term aging. So, for the long term aging, you should have with you the short term aged binder, because this is the aging after the short term aging. So, long term aging happens during the service life. Now, the tests which are widely used for the determination of aging characteristics or the aging of a bitumen are: one is thin film movement test, second is rolling thin film movement test, and third one is pressurized aging vessel test, PAV aging test, which is there. So, and we have the ISO specifications 9382, which is for testing determination of effect of heat and air by thin film oven. Then we have IS 15799, which is for the aging of bitumen through RTFO and PAV test. Now, quickly what is done in this particular one? In a thin film oven test, which is conducted to determine the short term aging of a bituminous binder, we take a standard sample around 50 gram of a binder sample is taken. It is poured in the pans, and then these pans are having a standard dimensions, and because of this standard dimension, there is a standard thickness of, or the film is which is constructed. So, if I pour this 50 gram of a binder in this pan, approximately a film thickness of 3.2 mm is created, and then this is transferred to this oven. There is a shelf over which this particular pans after pouring of binder. So, I have poured the standard requirement of 50 gram in these standard, these pans are of standard dia as well as the height, and then they are transferred to this particular oven where a rotating shelf is there. So, you can place 3 such pans in it, and then this rotating shelf moves at a standard speed. So, it moves at a rotational speed of 5.5 revolutions per minute, and the oven temperature is maintained at 162 degrees centigrade for a duration of 5 hours. So, with this 5 hours at 162 degrees centigrade and this revolution speed, we are trying to simulate the aging which can happen during the production and construction of the bituminous mixes. So, once this binder has aged, you will take it out this binder, and you can determine its consistency before short term aging, and you can determine its consistency after short term aging by thin film oven to see a comparison that how aging susceptible your binder is. And you want a binder to be less aging susceptible, because its viscosity and other important characteristics should not get affected much by this particular production process and construction process. There is another modification of this thin film oven test, is a rolling thin film oven test. At the word itself says it is a rolling, and nowadays it is more preferred specifically. Again, here we take a standard weight of bitumen. These are the glass crucibles which are there. You can see they are pouring the binder to it, and once the binder is poured, this is rotated and so as to have a good dispersion of the binder. Then there it is again moved to a shelf where these bottles are inserted. So, there is what is the container is then placed in the open oven carriage, and in this particular carriage where these are going to rotate. So, you will place these cylindrical bottles in this particular manner, and they will rotate along this axis. So, this will rotate in this particular manner. Now, when it rotates in this particular manner, the chances of any film formation which was there in thin film oven test gets reduced, and along with it, during this particular part there is an air flow which is there, and air flow will be there which will be projecting. So, any formation of a film is getting reduced because of an air flow, and this one is this rotates at a speed of around 15 revolutions per minute, and the test is done at 163 degrees centigrade, and it produces the aging which we did with the thin film oven in 5 hours. Here we get the similar amount of aging in 85 minutes. So, we are able to produce more of short term aged binders in a smaller duration of time, and there are reduced chances of any skin formation specifically with this. So, the RTFO produces a similar degree of hardening as thin film oven, but in a shorter period 85 minutes, and can handle more samples simultaneously, because you can insert around 8 bottles in this particular one in one go compared to the 3 pans which is usually used in case of thin film oven. And it is preferred for testing modified binders because its rotating action prevents any skin formation of the sample. So, this is again some of the common issues because of which now this rolling thin film oven is widely used. Now, the last one comes up under the aging protocol is the pressure aged vessel, which is to see how the aging happens during the service life of the bituminous mixes. So, for this particular one, a vessel which is used is known as pressure aging vessel, because here you do the aging without raising the temperatures to higher temperatures of this particular one by applying vacuum by applying the pressure at higher at temperatures ranging from 90 to 110 degrees centigrade, and applying a pressure. You are trying to simulate the aging which can happen for a period of around 5 to 10 years of life. So, in pressure aging vessel, this is how a pressure aging vessel looks like. This is a pic of a pressure aging vessel where actual testing is undergoing. So, here again a pen is there. So, the short term aged binder has to be used for this pressure aging vessel. So, what you obtain from thin film oven or the rolling thin film oven has to be used in this particular one. Again, as a quantity of RTFO aged, standard quantity of it is to be aged, and then when you pour it then in these standard pens, you get a standard thickness, and then it is subjected, this pressure vessel is there where it is subjected to an air pressure of around 2.1 megapascals and temperatures of 90, 100 and 110 degrees centigrade, which depends upon the grading of the binder. Harder grades are or softer grades are there. So, that we will discuss later stage, but it is subjected to a temperature around 100 degrees centigrade, and this test is done for a period of around 20 hours. So, then the binder which is obtained out of it is subjected to some certain small process, so as to remove any entrapped air, and once that is there with us, we have the short term aged binder also. This is short term aging, short term aged and long term aged. So, we will have the short term aged binder and long term aged binder. Now, we can compare the characteristics of these binders, which may be in terms of softening point or in terms of viscosity, how much is the change in the viscosity which is happening once it undergoes short term aging, how much it happens when it undergoes the long term aging. So, these are some standard process to determine this particular. Now, another test which is done to ensure the quality of a binder for road applications, bituminous applications, is the purity part. Normally, what we get from the refining of the petroleum crude from the standard refineries, we get good quality of binder from refineries, and that binder is mostly completely soluble in solvents like toluene or trichloroethylene. But if because of any reason during the transportation or during the production there are certain impurities introduced in it, that we can ensure by checking, by dissolving it, these binders into these standard solvents, and approximately there is a standard process which is done as per IS 1216. It says approximately 2 gram of binder sample is placed in a conical flask. This is there. So, to which 100 ml of trichloroethylene or toluene is also preferred is added for dissolution. The mixture is then filtered through gauge crucible. This is a specific crucible, and the insoluble residue which is collected on the pad is washed, dried and weighed. So, I can get how much is the residue is retained on this particular one, then this will give me an idea how much impurity is there. So, this specifically the impurities, as I said, when you get from refineries, the chances of impurities are quite less, but during the transportation by moving it from different tankers, and if some impurities are intentionally introduced, this is a check which can be done, because as I mentioned, nowadays it has become a very costly material. Another aspect which needs to be ensured whenever a material is to be used, whether, since as I mentioned they have a volatiles in it, this is a hydrocarbon, bitumen is a hydrocarbon. So, when you raise the temperature, there are fumes are generated, and these fumes can catch fire. So, normally the temperatures which are used in the production temperatures are much less compared to at what temperatures it can catch some fire. But then also it is important to ensure from the safety aspect what are the safe handling temperatures. So, for that particular one we have the flash and fire point test. So, it says when heated to a sufficiently high temperatures, bitumen emits vapors that can ignite upon exposure to a flame. So, you can see certain, this is a binder plant, hot mix plant which caught fire because of this reason. So, if there is a certain mishappening which can happen if we are not able to control the temperatures up to which these binders gets heated up. So, one temperature which is referred is the flash point, is the temperature at which bitumen can be safely heated without the risk of sudden ignition, and this temperature is much lower than the fire point where the material starts actually with the combustion of the material starts. So, two temperatures are referred, flash point and fire point. What we measure is flash point, which is normally 10 to 15 degrees centigrade, lower than your fire point, and we will try to get and ensure that the flash point of binders should be quite high compared to your production temperatures. So, the flash point of a material is the lowest temperature at which application of a test flame causes the vapors from the material momentarily catch fire in the form of a flash. So, I can heat a binder sample and I can reach to temperatures where vapors will get generated. If a flame is brought near to it, if you see some flashes, then you can call it as a flash point. And if you further heat this particular one, then the material starts burning, it ignites. So, that is your fire point which is there. So, we do not check for the fire point, we check for the flash point. And there is a standard Cleveland open cup method is there, where you pour this binder into this particular one and you gradually heat it, and you are going to bring a flame on the top of this particular one, and you are going to see where the this flash is occurring, because when the vapors are there formed at higher temperatures. So, normally it is well about 220 250 degrees centigrade, it is in the range of 220 to 250 degrees centigrade for different bituminous binders. So, and we do the production of bituminous mixes in the temperatures of 150 to 180 degrees centigrade. So, these temperature, but still one needs to ensure from the safety point of aspects that because of some contamination or some impurities, there may be chances that the flash point may get lowered down. So, flash point is also used to detect presence of some volatiles. As I mentioned, because of some impurities, specifically what happens, the kerosene, the presence of kerosene, which may resulted from switching transport tankers, because this is from one tanker to other tanker, and when the cleaning of these bitumen tankers is done, so that time some some remains of kerosene may be there, which is highly volatile. So, that may reduce the flash point. So, that is why flash point is to be ensured for the binder samples which you are going to use for your construction purpose. Another one more test which is used is your ductility test. Now, in this particular ductility test, what is done, a binder sample is taken in a special mold and you stretch the binder sample. When you stretch, you are going to measure how much elongation or how much you can stretch a binder sample. You will always prefer that it is stretched to a good amount before it finally ruptures. So, a binder should show a good amount of ductility, and it has been referred that a binder with a good ductility shows a good performance, specifically in terms of the cracking of those bituminous mixes. So, the ductility of a bitumen is measured by the distance in centimeters it is stretched before breaking. So, this is a special briquette in which it is poured. Standard dimensions are there given in 1208 part 1, and when you stretch it in water bath why? To maintain a standard temperature, it is kept in water bath and it is stretched. So, here it is getting stretched, both the ends are getting stretched, and you stretch it at a standard rate. It says 5 centimeter per minute. So, you are going to stretch it at a standard rate, and specifically again here one important aspect is to ensure the specific gravity of the binder and the water is to be more or less same. So, otherwise what happens, if the density of water is quite less, then it may float, or if this particular is more, then it may float. So, we try to increase or decrease the density of the water by adding salt. We increase it by adding salt, we decrease it by adding some alcohol to it. So, these are again some precautions which are to be there as per IS 1208, and then the ductility is measured. There are minimum values specified for the binders that it should go at least this much amount of elongation, and we can, it is more preferred if we do the this ductility measurement over an aged binder, because that is the short term aged binder, because that is the binder which will be actually available in the field after construction. And so for research purposes, this can be done at lower temperatures also, instead of 25 degrees centigrade, at 15 degrees centigrade and 4 degrees centigrade. But when it is done at lower temperatures, we normally reduce the rate at which these two ends are stretched also. So, instead of 5 centimeter per minute, the rates are many a times reduced to 1 centimeter per minute when we are doing at a lower temperatures like 4 degrees centigrade or, for the ductility measurement. But the standard one is done at 25 degree centigrade at a rate of pull of 5 centimeter per minute. Now, this table shows you the requirements of different these properties which we have measured, and then here you can see it says the requirements of a paving bitumen. Now, in this paving bitumen, one new thing is there are 4 different grades which are shown here, but each grade have requirements in terms of penetration, absolute viscosity, kinematic viscosity, flash and fire point, solubility, softening point. Then there are ductility and viscosity ratio. So, all these tests we discussed. So, there are these grades are formulated for their applications in different regions. So, specifically where you require depending upon the maximum temperatures and the lower minimum temperatures which undergo in different regions, the amount of loading which is going to come different. VG40 for the beginning part, we can in general we can say VG40 is the most harder grade, stiffer grade compared to VG30. Then we have VG10 and V20, and VG10 is the softest grade. Now, here you can see this gives what should be the requirement of a penetration test done at 25 degree centigrade. For say VG20, it says minimum value of penetration should be 60. Now, similarly, it says absolute viscosity value should be in the range of 1600 to 2400, and as I mentioned, these are more harder grades. So, the viscosity requirement of VG10 is 800 to 1200, and that of VG40 is 3200 to 4800 poise. So, as this is a harder grade, the absolute viscosity will be higher for VG40. Similarly, it will be there for kinematic viscosity also. Here the requirement is minimum 250, here it says that the requirement is minimum 400 centi-stokes. Then flash point, as I mentioned, it is in all cases it has to be more than 220 degrees centigrade. Solubility and the purity is to be ensured, and it should be 99%, more than 99% have to be soluble in a solvent like toluene or trichloroethylene. Softening point, again for a softer grade of binder it is less, and for a harder grade of binder it is more, and the requirement is given. And then there is a as I mentioned, ductility is a good test to be conducted on a short term aged binder. So, after doing the aging, it says test on residue from rolling thin film oven. So, it is an aged sample which you are, these are the short term aged samples which you are using. So, here what you do, one is a ductility measurement, and it says that the ductility values should be at least stretched by 75 centimeter for a softer grades, and for the hardest grade at least 25 centimeter. So, this is the ductility requirement. If it does not meet the requirement, that binder cannot be accepted for your use. And viscosity ratio, because again the binder should not be highly susceptible to aging. So, this is the viscosity of aged binder with respect to the unaged binder. So, we are going to measure the absolute viscosity at 60 degrees centigrade of unaged and aged, and this ratio should not be more than 4. So, this is what is ensured through this IS 73 2013 paving bitumen specification. So, this is how it is important to understand, know what are the individual characteristics which are required for the binders to be put for different applications. Now, MORTH, like this is one table where MORTH says that okay, if you want to use, where should you use VG10, where should you use VG20, where one can use VG30. It says that the lowest daily mean temperature, air temperature is more than 0.10 degree centigrade, and maximum highest daily mean temperature is less than 20, there you can go for VG10 binder. So, depending upon the highest daily mean temperature and the lowest daily mean air temperature, you can decide this grade. And similarly, it is say for this particular one more than 30 degrees centigrade, and this is more than minus 10 degrees centigrade, you can use for VG30. So, similarly, it is given for VD10, 20, 30 and 40 in your IS 73 specifications. So, on the basis of the requirements of the temperatures which undergo in different regions, these different grades of binders are used in road. But our important aspect is we need to ensure what are the requirements in terms of different parameters, viscosity, the softening point, penetration, ductility, whether the binder which is supplied to us for that particular use is meeting those requirements. It has to be ensured properly. If not, we have to reject that particular one and we have to look for the another source which pass all the requirements. So, this is all about the bituminous binders characterization. Thank you.